Right. So a mole is a measurement of a number of something. When we talk about eggs, you can talk about a dozen eggs, and there we're talking about 12. There's another number we could use that way would be sometimes people will talk about a baker's dozen, which is 12 plus 1, so 13. There's an old unit of measurement like that called a gross, which is a dozen dozens, or 144 of something. Now a mole is just a really big number of something. And a mole is given to us by Avogadro's number, and the symbol for that would be N and then a little A after it, and N for number and then the A for Avogadro. And it's named after an Italian guy whose last name was Avogadro, and it is 6.02 times 10 to the 23rd of something. And so the idea would be, if you wanted to write this out in non-scientific notation, you would have moved the decimal place 23 places to the right. So you would end up with, if I recall correctly, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So assuming I moved that 23 places, we would have this number of anything, really, would be 1 mole. Now, if you took that many high school textbooks, we could cover Canada to a depth of about 320 kilometers. Water flows over Niagara Falls at about 650 million liters per minute. At that rate, it would take about 134,000 years for not 1 mole of liters, 1 mole of water drops to flow over the falls. Avogadro's number is roughly the number of milliliters of water in the Pacific Ocean. Mount St. Helens erupted in 1980, and if 1 mole of particles the size of sand grains had been released, they would have covered the entire state of Washington to the depth of a 10-story building. So you're getting, hopefully, the idea that a mole of something is lots. Okay. Now, a mole, generally we don't talk about a mole of moles, but if we did take a mole of the animal moles, we place them head to tail, they would stretch about 11 million light years and weigh 9/10 as much as the moon. If we took a mole of marbles and each of them was 2 centimeters in diameter, they'd make a mountain 116 times larger than Mount Everest, where the base of that mountain would be slightly larger than the area of the United States. Now this one's just me being goofy. A guacamole, we could say, is the amount of taco chip dip that can be made from an Avogadro number of avocados plus appropriate quantities of tomatoes, onions, and chili. A train stretching to the North Star, which is about 680 light years away, and back 2.5 times would be required to transport 1 guacamole. Moles and mass can be related using the molar mass given on the periodic table. The molar mass of carbon is 12.01 grams per mole. This means that 1 mole of carbon has a mass of 12.01 grams. These are related through this formula. You're going to use it a lot throughout high school chemistry, where N is the number of moles, little m is the mass in grams, big M is the molar mass. And the units for molar mass would be grams per mole. So if we are given a periodic table, and that's going to allow us to get the molar mass, and then either mass or number of moles, we can calculate the other one, the moles or the mass. If we do have both moles and mass, we could calculate molar mass as well. If we didn't have the periodic table, or if we were trying to find out what some substance was. Now, to find the molar mass of a chemical compound, we simply add up the atomic mass of each atom present in the compound. So, find the molar mass of water. Here's our first example. So the first thing we need to do is write out the chemical formula for water, which is H2O. Right, and then we look at this and we say, okay, the molar mass of this, well, there's 2 hydrogens and 1 oxygen. So we look at our periodic table. And the way I always write this is I say, okay, there's 2 H's, so I'm going to write 2 times H. There's 2 hydrogens, and we have 1 oxygen. 1 times O. And this is going to equal, and then I've got 2 times, and I look under the hydrogen on the periodic table, and it says 1.01 in the, I guess not under, on the top right-hand corner. 2 times 1.01. And I take 1 times the oxygen says 16.00, and so here I have 1 times 16.00. I should not forget my equal sign. So this is equal to 2.02, and this here is equal to 16. I now add them up, so in this case it's 2.02 plus 16. And I'm left with a grand total here of 18.02 grams per mole. So that means 1 mole of water has a mass of 18.02 grams. So if you have 18 grams worth of water, you have roughly, so if you have 18.02 grams of water, you then have 1 mole of water molecules. So you have 6.02 times 10 to the 23rd water molecules, or that many water molecules. Okay. Alright, so what else can we do with this? Well, we could find out how many moles are present in 25 grams of sodium sulfate. One of the things you're going to have to recognize here is that you got to be able to go from the name to the correct formula. So sodium sulfate is Na2SO4. Very first thing I need to do is find my molar mass, my big M. So I should label this up here. Big M is equal to that. Here I've got M, so I want to find my molar mass, of sodium sulfate. Well, I have 2 times sodium, and we look on our periodic table. This is going to be 2 times, and we look for sodium, 22.99. Okay. Then we're going to look and we say, okay, there's 1 times sulfur, which is going to be 1 times 32.07. And I have 4 oxygen, so I've got 4 times oxygen, which is going to be equal to 4 times 16. So we've got a grand total here, and this is going to probably require a calculator. I can do this in several steps or all in one step. So 2 times 22.99, make sure you type in all the number. You end up with 45.98. Plus 32.07. That's easy multiplication to do in your head. And this is going to be 64. we add those up, and our molar mass is going to be equal to 45.98 plus 32.07 plus 64 is 142.05. And again, my units here are grams per mole. Alright, now we're asking for how many moles are present in 25 grams of this stuff. Now I look at this and I say 142.05. Hey, that means 1 mole has a mass of 142.05 grams. Which means if I have 25 grams, it's going to be less than a mole, which is just a good way to kind of check the reasonableness of my answer. So I use my formula again. Moles is equal to, and this is it up here, little m over big M. So this is going to be equal to, this is my mass that I'm given, 25 grams. That's going to be divided by 142.05 grams per mole. And so we do the division, 25 divided by 142.05, and we get a grand total here of 0.176 grams. We're going to talk much more in the physics unit about significant digits. I'm going to just leave it there for now that there are 3 numbers here which mean that are other than the leading 0, and so I need to have 3 numbers in my answer. And the last example here. How many grams are present in 1.53 moles of uranium-6 fluoride? So again, uranium-6 fluoride would be UF6. Okay. Pause it at this point. See if you can figure out the molar mass of uranium-6 fluoride. Really, pause it. Hit pause, get out some paper, pencil, pen, calculator, do it. Pause it. This means you. Alright, so I've got 1 times uranium, and so that's going to be 1 times, and we find uranium. That's going to be 238.03. That's math I can do in my head. And I have 6 times fluorine, which is going to be 6 times, and we find fluorine on the periodic table, that's going to be 19. Which is 114.00. I add those up. 114 plus 238.03 is going to be 352.03 grams per mole. Alright, now the question is asking how many grams are present in 1.53 moles. So I start with this formula again. N is equal to M over big M, little m over big M. I want to get the mass by itself. Mathematically, to do that, I multiply both sides by big M, which gets rid of them on the bottom over here. And I'm left with M is equal to moles multiplied by molar mass. M then is equal to, my moles are given right here, 1.5, ooh, that's a terrible 5, 3 moles multiplied by my molar mass of 352.03 grams per mole. And that's going to be equal to 538.6. Again, I'm looking here, I see 3 significant digits. So we're going to round that to 539. And that's going to be grams. Right, so these 3 examples, which if you haven't written down already, rewind the video, go back so that you don't have the answers in front of you, and work through them. These will get you started, and now you have enough to finish up the rest of your book. Thanks, and get to work.